We now discuss the solution of a problem from the section Differential Calculus. The question is on the increasing and decreasing functions. This question has appeared in the joint entrance examination main held on 25th June 2022 in the first shift. The given question is, let g be a function from the open interval 0 to infinity to the set of real numbers, and it is given to be a differentiable function such that integral in brackets first is a quotient whose numerator is x into in brackets cos x minus sin x by the denominator e power x plus 1 plus again a quotient g of x multiplied by in brackets e power x plus 1 minus x e power x by the denominator e power x plus 1 whole square. The outside bracket closes, and this is to be integrated with respect to x, and this is given to be equal to x times g of x by in the denominator e power x plus 1 plus c for all x greater than 0, where c is an arbitrary constant. Then we are given four options. Option A, g is decreasing in the open interval 0 to pi by 4. Option B, g prime is increasing in the open interval 0 to pi by 4. Option C, g plus g prime is increasing in 0 to pi by 2, open interval 0 to pi by 2. Option D, g minus g prime is increasing in the open interval 0 to pi by 2. So we are having a differentiable function g defined from the open interval 0 to infinity to real numbers, and it is given such that the integral of this function is equal to xgx by e power x plus 1 plus c, and this is true for all x greater than 0 where c is given to be an arbitrary function. Then we have to discuss the increasing and decreasing nature of the functions g, g prime, g plus g prime, and g minus g prime in the given open intervals. That is the question. Let us now discuss the solution of the problem in detail. Given g is a function from the open interval 0 to infinity to real numbers, and it is a differentiable function, and it is given like this. The integral of this in brackets a function with respect to x is equal to x g of x by e to the power of x plus 1 plus c, true for all x greater than 0 where c is an arbitrary constant. So what we do is, because we have to talk about gx, g of x and g prime x, so on and so forth, so we will now differentiate both sides with respect to x. Then the differential of the integral will be the function. So because the differentiation and integration are inverse to each other, right? So differentiate, you will get x in brackets cos x minus sin x by e power x plus 1 plus second term g of x into e power x plus 1 minus x e power x bracket close by e power x plus 1 whole square. So these are the two terms is equal to, this is to be differentiated using u by v formula, that is a quotient formula. So you will have the denominator square e power x plus 1 whole square, the denominator e power x plus 1 into the derivative of the numerator. The numerator is a product, so use the product rule. So in brackets x into derivative of g of x plus g of x into derivative of x is 1 minus numerator x gx multiplied by the derivative of e power x plus 1, that is just e power x. Now take the LCM on the left hand side, take the LCM. So that will be e power x plus 1 whole square is the LCM. Then what happens is you have to multiply the first term by e power x plus 1. So e power x plus 1 into x into cos x minus sin x plus the remaining things as it is, because you have taken the LCM. Now here it will be the same, but what we have written is e power x plus 1 multiplied by x into g prime x, that is this one. So e power x plus 1 multiplied by g of x, this is the second term. That means just this bracket is open. So this is what we have. And the denominator e to the power of x plus 1 whole square, e to the power of x plus 1 whole square is common. So the denominator is same, cancelling the denominator. We need not worry because e to the power of x plus 1 is not 0 for any value of x. Therefore you cancel off. Then you will get the numerator is equal to the numerator, that is equal to this one. So in this, what I have written, g power x into e power x plus 1, that is a one term, minus g of x into e power x plus 1 minus g of x into x e power x, and written this in the red, this in the blue we have written. And now come to the right hand side. So you will get e to the power of x plus 1 into x g prime x plus the second term written in red and minus the third term is written in blue. And what you see is the red terms are equal on both sides and minus the blue terms are equal. So cancelling these two terms on both sides, we get e to the power of x plus 1 into x into in brackets cos x minus sin x is equal to e to the power of x plus 1 into x into g prime x. Agreed. Again, e power x plus 1 we cancel off because it is not equal to 0. No worry. And we will also cancel x. Why? X is not there in the domain of the function g. Therefore, x is not 0 for g. So therefore, because x not equal to 0, you will also cancel that term. So you will get, that will be cos x minus sin x is equal to g prime x. So g prime x is cos x minus sin x. We continue in the next slide. So we have g prime x is equal to cos x minus sin x. Let's call this as the equation 1. Now to get g of x, we integrate both sides with respect to x. So yeah, before that, the g prime x is equal to cos x minus sin x. Yeah, we want to discuss the nature of g prime x, that is increasing, decreasing nature of g prime x first. Now, cos x minus sin x, we multiplied by root 2 and divided by root 2. That is root 2 multiplication, cos x into 1 by root 2 minus sin x into 1 by root 2. So this is cos x cos pi by 4 minus sin x sin pi by 4. That will be equal to cos of x plus pi by 4. So root 2 into cos of x plus pi by 4. And this g prime x, increasing, decreasing nature, we have to discuss in the interval 0 to pi by 4. Therefore, I will take x belongs to 0 to pi by 4. Right. So if you have the graph of cos function, root 2 times means it is the scaling takes place. Scaling means in this case root 2 is greater than 1. It bulges, that is the curve will bulge vertically. Vertically it will bulge. But anyway, the curve will remain same. That means the continuity, differentiability, increasing, decreasing natures, all these things are not disturbed. They will remain same. So now this is your cos function, cos x, and x is equal to pi by 4, x is equal to pi by 2. Suppose now you take x is 0, then x plus pi by 4 will become pi by 4. That means cos pi by 4. And when x is equal to pi by 4, it will be pi by 4 plus pi by 4, that is cos pi by 2. That means what happens? What happens? Cos pi by 4 and cos pi by 2 here, it decreases. That means it decreases from cos pi by 4 to cos pi by 2. This one. For x belongs to 0 to pi by 4, cos of x plus pi by 4 will decrease from cos pi by 4 to cos pi by 2. So note that cos of x plus pi by 4 decreases from cos pi by 4 to cos pi by 2 as x varies in the interval, open interval 0 to pi by 4. It is a decreasing one. Therefore, what happens? Thus, g prime is decreasing in this interval, in 0 to open interval 0 to pi by 4. What is given in one of the options? Option B says g prime is increasing in 0 to pi by 4, but we got it is decreasing. This is the truth. This is the correct statement about g prime because we have derived. Therefore, the option B is not true. So we have ruled out the option B. Now let's continue. So in the next slide, we take g prime and integrate, we get gx, and we will decide about gx, the increasing and decreasing nature of gx as required. So we have the equation 1. Now integrating with respect to x, the integral of g prime x is gx is equal to integral of cos x minus sin x with respect to x plus c1, where c1 is the constant of integration. Now what we have, integral of cos x is sin x, integral of minus sin x is cos x. So this is sin x plus cos x plus c1. Therefore g of x is equal to sin x plus cos x plus c1, and let's take this as the equation 2. Agreed? Now again use the same technique for sin x plus cos x, that is multiply sin x plus cos x by root 2 and divide by root 2. That means multiply by 1 by root 2. So root 2 into sin x into 1 by root 2 plus cos x into 1 by root 2. So this is a sin x cos pi by 4 plus cos x sin pi by 4. That is root 2 times sin of x plus pi by 4. So this you can write it as. So that is g of x is equal to root 2 times sin of x plus pi by 4 plus c1. So what is happening here? What's happening here? It is the scaling takes place. Scaling is root 2 greater than 1. It bulges plus c1. That means the graph will move upwards. Will move upwards by c1 units. C1 units. If c1 is positive, it moves upwards by c1 units. If c1 is negative, it moves downwards by mod c1 units. By mod c1 units. So this is your sine curve. Sine curve. Suppose C1 is positive. Of course, scaling also takes place. C1 is positive. So scaling and it translates upwards. So by C1 units. If C1 is positive, it is by C1 units it will go up. And if C1 is negative, it will go down vertically, downwards like this by mod C1 units. But the continuity, differentiability, increasing, decreasing natures and all these things will remain same under scaling and this translation upwards. So what is that we are going to now discuss about gx? So note that sin of x plus pi by 4 plus c1, what happens? When x is equal to pi by 4, when x is equal to 0, it will be sin of pi by 4 and plus c1. And when x is equal to pi by 4, it will be sin of x plus pi by 4 plus pi by 4, that is sin of pi by 2 plus c1. So it increases because it increases. So it increases from sin pi by 4 plus c1 to sin pi by 2 plus c1 as x moves from 0 to pi by 4. So like this. Wherever you are either here or here or here, whatever it is. So it takes place. So it increases. So this implies G is increasing in the open interval 0 to pi by 4. But what is given to us in the options? Option A says G is decreasing, but we have derived that it is increasing. Therefore, the option A is not true. Okay, we move on to the next stage. So we have the equation 1, g prime x is equal to cos x minus sin x, and g of x is equal to sin x plus cos x plus c1. That is the equation 2. So let's add. Adding, we'll get g of x plus g prime x is equal to 2 cos x plus c1. It is 2 times scaling and the translation. That means it shifts along the y-axis. Plus c1 means along the y-axis. It shifting and scaling. Here it is scaling, it is shifting upwards. So this is to cos x. What happens in 0 to pi by 2? 0 to pi by 2, we all know that cos x decreases. So 2 times cos x decreases, 2 times cos x plus c1 decreases in the interval 0 to pi by 2. So what is given in options? Option C says g plus g prime is increasing. So in the interval 0 to pi by 2, therefore the option C is not true. Agreed. Now subtract. So g of x minus g prime x will be 2 times sin x plus c1, again scaling and shifting upwards. Right. So the properties will not change, so that is the thing. And this will be is increasing in 0 to pi by 2. Sin increases in the interval, open interval 0 to pi by 2. Cos decreases in the open interval 0 to pi by 2. So that's the one. So what is given to us? Option D, g minus g prime is increasing in 0 to pi by 2. Yes, this is true. Therefore, the option D is true. So the answer to this question is option D. You might have noticed that this problem entirely depends on the increasing decreasing nature of cos x graph and sin x graph. That's all. That is the only thing that is there in this problem. Of course, if you know scaling and shifting, it will be very easy, and that means you can convince a lot from this shifting and scaling. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.